Hello and welcome to video 4, lesson 4 in Spiral 4. So today we're looking at other rates of change. And remember, rates of change, that's equal to first differences. That's also equal to unit rate. All three terms mean the same thing. Depends on the context. So I can demonstrate the rate of change from a graph or a table is our goal today. So the two examples we're going to go through. So the first one, at a flea market, you notice a stand that allows you to string your own necklace. So they give you the wire, okay, and you put the beads on. That's basically what's happening. You purchase a wire, and then you pay a set price for each bead. So each bead is going to cost so much money. So this is the graph that illustrates the relationship. So you're going to see something like this on EQAO. So you get a graph that shows the relationship. Can you come up with a T-chart based on the graph? So let's just make sure we can do that. So at 0 beads, so I'm starting right here, at 0 beads, it will cost me $4. 1 bead, I'm not a big fan, it's tough to read that number. I'm going to go all the way up to 4. So 4 beads will cost me $5. All right, so we're going to figure out what the unit rate is, okay? Now, it's tough to read off the graph, so at 1, 2, and 3, very, very tricky to figure out here. But here's the key. Between 0, all right, different color pen here, so between 0 and $5, those are the two values I could read, it went up once, twice, 3, 4 times. All right. So if we look at that, so the price, all right, so the cost went up $1 for 4 beads. All right. So again, I just clear that off. I went up $1 and across 4 beads to get to my next point. So if I just use the graph, I find that $1 for every 4 beads. That means that if we get down to a unit rate, it is 0.25 per bead or 25 cents per bead. So that's my first difference because this is a unit rate. All right, so from the graph, I found a unit rate. All right, and because unit rate is equal to first differences, I now know that we're going to go up by a quarter each time. All right, so we're just using our graph to find that unit rate, same as what we did when we did partial and direct variation last unit. So if I put 1 bead on, it's 425, 450, 475, and it works out, 525. So there we go. So answering the question over here, what does the unit rate represent? Well, we already did that up here. Let's bring that answer down. So the unit rate is 25 cents per 1 bead. All right. So that is what our unit rate represents. So they're charging you 25 cents a bead. And the last question, why does it cost something if you don't buy any beads? So here we have bought 0 beads. It's $4. So I'm just going to get this up higher so I can write. So for 0 beads, it costs $4. Why is that? Why is that? Again, don't put your hands up. I can't see you, okay? You look silly. Put your hands back down. All right. Because you're paying up front. What's the $4 cost, or what's the $4 buy you? Okay, the wire. All right. So the wire that you're going to use for your necklace, the wire for the necklace, and they are making a killing here because that is a huge markup. The wire for the necklace costs $4. All right. So you had to pay up front. That's your initial value. You're not buying a wire each time. You bought 1 wire. So that's $4 up front and then 25 cents for each bead. All right. So that's the first relationship we're talking about. If you look at your other example, a water tank is being filled. The table below shows the volume in kiloliters, don't know why we're using kiloliters, of water in time. Confirm the relation is linear. So how can you figure this out? If it's linear, so this is going back to spiral 2, we need to do first differences. So what's happening on each jump here? So we do our calculations. We see we're going up by 30, up by 30, up by 30, up by 30, and just to double check, you got to find the other side just to check to make sure they're not doing anything funky over here. So we're going up by 20 each time, so therefore this is linear. So therefore, the first difference is the same, so it is linear. All right. B says graph the relation on the grid provided. Okay. So x-axis on the bottom. So it's time, volume. We go up to 80, so I'm going to go up by tens. All right, so 10, 20 on the other axis. I got to go up to 140. So let's go up by 20s. 20, 40, 60, 80, 100, 120, 140. Perfect. All right. So plotting my points. Here's some red. So 0, 20, 20, 50, 20, 40, 50, 40, 80, 10, 20, 30, 40, 40, 60, 80, 60, 2, 3, and 110, 20, 40, 60, 80, 100, 110, and the last one, I was at 6, 7, 8, 140, that was 10, 20, 40. There we go. So look at that. Using a ruler, it is a linear relationship. All the points plot on there. So graph it. So C graph. Excellent. Next, what does the unit rate mean for this situation? Well, what is the unit rate? Let's start with that. So there are a couple of ways we've talked about it. Method number 1. From T-chart. So first differences equals, so it goes up 30 for every 20 minutes. All right, so we want to write that as a unit rate. So 30 divided by 20 is 1.5. Number 2 from graph. Since you have the graph, so we started here. Let's go up to a nice easy point. So I went up 20, 40, 60. I went up 60 and across 40. So I went up 60 and over 40. So that comes out to be 1.5 as well. So either method you want is at your disposal. What does the unit rate mean for this situation? So look at your original, your first differences. The 60, what does the 60 represent? That's kiloliters. Over here, 30 kiloliters. So that means it's going to be, therefore, 1.5 kiloliters. And on the bottom is minutes. So it's per 1 minute. All right, so 1.5 kiloliters per minute. All right, there we go. And last one, last question. Why was the volume 20 kiloliters when the time was 0? All right, so why does the graph, why is it starting at 20 if we're filling a tank? I'll give you a second to think about this. All right, so why did the volume start at 20? What's the reason? Again, I can't see your hands. Put your hands down. You look ridiculous. The reason is there was water in the tank to start. So there was water in the tank to start. All right, so probably probably someone didn't do their job. So for example, let's call this person Porter for argument's sake. So Porter was told, empty the tank out before we start doing the next job. And Porter doesn't do his job. He goes, surfs on his phone rather than doing what he's supposed to. So when they go to start the next job, there was already water in the tank. Okay, someone didn't empty the tank. There was water there to begin with. Someone didn't do their job, Porter. So this is what happens. We end up, instead of starting with a volume of 0, we already have 20 kiloliters in the tank at time 0. All right, so there's an example of a partial variation and using that information in a variety of ways. Okay? If you have any questions or need anything clarified, make sure you stop and ask your teacher. Good luck on the homework assignment. We'll see you in the next video.